Hey guys, this is going to be the Unit 1 review video. So on number 1, we're asked to add f of g together with 4 plugged in for x. So you're literally doing f of 4 plus g of 4. Remember, f of 4 just means take the function f and replace each of the x's with a 4. So I'm going to be doing 3 times 4 squared plus 2 times 4. Same thing with g of 4. I'm taking the function g and I'm plugging 4 in for x. Now I need to simplify. So I've got 4 squared is 16. 2 times 4 is 8. 12, 2, 48, multiplying 3 times 16, 48. And then we're just going to add those numbers together. Let's see, that gives me 20 plus 50 is 70. And that's it. Okay. So you're plugging in 4 and adding those two together. Number 2, that might be a little too dark for, light for us. Let's get a darker color. Sorry. Number 2. We're doing g of f of x, which remember these parentheses are just telling you to plug something in. And so they've replaced the x that you normally see right here with f of x. So that's what you're going to do. You're going to replace the x's in this function with f of x. So I have 3, for the function g, I have 3x plus 2, but instead of x, that's where I need to plug in f of x. Well, f of x is 3x squared plus 2x. So I've substituted 3x squared plus 2x there. Now we need to simplify it, so I'm going to distribute this 3. Multiplying. Okay, now if you could combine like terms right here, you would want to, but no like terms. We've got x squared, x, and then no x on the last one. So that's as simplified as it gets. All right, number 3. Okay, so this time we're dividing. It says f divided by g of x. So that is literally f of x over g of x. F of x is 3x squared plus 2x. G of x is 3x plus 2. So there it is. But we can simplify, right? So we need to factor here. Now the tempting thing to do is a lot of people just want to like maybe cancel the 3's, cancel the 2's, but that is not an option. When there are plus or minus signs involved, you can't start canceling things. You need a factor first. And so I can factor an x out of the numerator. That's called a GCF. They both have an x. So I'll take that x out. I'm left with 3x plus 2. Well, how convenient is that? Look, I've got 3x plus 2 on the top, 3x plus 2 on the bottom. Those cancel. I'm just left with x. But not so fast. Remember, we do have restrictions on these, or we just have to check the domain. So because there's a denominator on this one, hopefully your mind was already going in that direction. The denominator, anytime you have a fraction, the bottom cannot equal 0. So that's going to be 3x plus 2 cannot equal 0. Subtract that 2 over. divide by 3. X cannot equal negative 2/3. So just put a comma. X cannot equal negative 2/3. So it simplifies to x, but x cannot equal negative 2/3. Perfect. Number 4, we're multiplying f times g. So that's going to be 3x squared plus 2x times 3x plus 2. Now, notice that you're multiplying here. There's no sign in between. When you see f and then that open circle and a g, that does not mean multiplication. That is the same as this notation. So this is f of g of x. Okay, so I noticed on the quiz, a lot of us, when we saw this, we tried to multiply the two functions, but this should be what's called composition, where you're plugging g into f. Not multiplying them, you're plugging g in for x. Plugging that function in for x. Okay, so those are different. Just notice that if you see it on the test. Okay, so if there's no sign in between though, we are multiplying, so f times g here, and we're gonna need to FOIL. So I'm going to distribute. All FOILing is distributing twice. Okay, so I'm going to distribute the 3x squared. It gives me 9x cubed. Distribute, that gives me 6x squared. Distribute the 2x, that gives me 6x squared. And distribute gives me 4x. Now I can combine like terms. Right here. They both have x squared. So that's going to give me 9x cubed plus 12x squared plus 4x. And that's it. All right, number 5. G minus f of x. So you're doing g of x minus f of x. Just subtracting the two functions. So let's see the two functions. I gotta zoom out. G is 3x plus 2. And then I'm subtracting f, which is 3x squared plus 2x. Notice I put those in parentheses. That is important because otherwise we're highly likely to forget to distribute this minus there. So you need to, when you plug something in, we always put it in parentheses so we don't forget something like that, where you need to distribute that minus sign. Okay, so that gives me 3x plus 2 minus 3x squared minus 2x. Okay, let's combine like terms. I'm going to write the answer in standard form, although that is not required for it to be counted correct. Negative 3x squared. Combine the 3x minus 2x. That just gives me x. And then I've got, did I write something down wrong? No. Oh, I wrote it down wrong on my key. Okay, I'll fix that. So then plus 2. All right, next page, we're going to be graphing some transformations. Okay, so anytime you have a number being multiplied by x on the inside, that is going to affect x. However, remember, anything inside with x does the opposite of what you would think. So right here, this 2, instead of multiplying x by 2, we're going to do 1/2 x. 1/2 x. So you're going to take each point, get the x value, and half it. And that's your new point. So starting right here, the x value is 1, 2, 3, 4, 5, negative 5. So half of negative 5 is negative 2.5, so it goes there. Or really, you can just move it halfway closer to the y-axis if you want, but the x value here is negative 2, so make it negative 1. Half of 2 is 1. Here, the x value is 3. Half of 3 is 1.5. 1, 2, 3, 4, 5. The x value here is 5. Half of 5 is 2.5. So that's your new point. So remember, if it's inside with the x, it affects x, but flip that fraction. Make it 1/2. All right. Number 7. These absolute value bars make y positive. Remember, f of x is the same thing as y, and absolute value makes it positive. So you're going to make y positive. Right here where it goes below the x-axis, you want to flip that reflected over the x-axis. So here's the new point. Anything that's below the x-axis, you're just reflecting it over. Okay, and then we want to trace the rest of the graph. Okay, so that's your new graph. That is the absolute value of that function, just making anything that was negative positive. Number 8, got a negative on the inside with the x, so it's going to affect x. You're literally going to do negative x. Take your x values, multiply them by negative 1. That's going to reflect over the y-axis. That's going to end up reflecting you over the y-axis. So here's what it looks like. If I take this first point here on the left and I multiply that x value by a negative, well, right now it's -3, so that would become +3, and here's my new point. See how that reflected over the y-axis? Okay, and if I take my next point, the x value is -2, that becomes +2. Here it's 3, so that becomes -3. And here it is 1, 2, 3, 4, 5, so that's going to become -1, 2, 3, 4, 5. -5. Okay, and then we can just sketch the graph. If the negative had been outside of the f, like this, then that would reflect over the x-axis. You would be making changing the sign on all of your y values, and it would reflect over the x-axis. All right, number 9, sketching these graphs. Hopefully we know our parent functions and then our transformations to be able to sketch these. So this is the absolute value function. So when you graph it, you should be doing the V shape. Remember, if it's inside with the x, it does the opposite of what you would expect. So this is going to go left 3. This -4 is going to make it go down 4. Always do your left and rights first before you do anything else. Okay, so let's go left 3, down 4, 1, 2, 3, and down 1, 2, 3, 4. That is your vertex. That is this point on the B. And now the slopes of each of those are 1, of each side is 1 and -1. What I mean is you're going to go up 1 over 1, up 1 over 1 to get your points. And up 1, back 1. Okay, and so that's how you get that V shape for absolute value. That's it. Number 10, this is our cubic function, so the graph looks like this, if you remember. But we've got a negative here, so that's going to be a reflection over the x-axis. That is because it's not grouped with x or anything, so that is affecting the y value. So that's -y, despite what it looks like. There's no parentheses, so technically if there were parentheses, it would just look like that. And so that is going to be reflecting over x. Okay, let's try it. So if I reflect that center point over x, nothing changes. However, normally on the cubic function, we have a point here. So if I make the y negative, it's going to be down here. See how that makes it reflect over x? Just moves it to the other side of the x-axis. Also, normally we have a point at 2, 8, because 2 cubed is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Normally you have a point here because 2 cubed is 8. But now we're multiplying our y by a -1. So it becomes -8. 2, -8. Okay, the other side of the graph, normally you have a point here at -1, but multiplying that by a negative makes it +1. -1 times -1 is +1. And then hopefully we can kind of get the picture that -2, -8 becomes -2, +8. So here's your new graph. Okay, and if you ever get stuck on that, you can always plug in some points. I could plug in 0 for x. 0 cubed is still just 0. So you'd have the point 0, 0 on the graph. If I plug in 2, 2 cubed is 8, so that's -8. So I have the point 2, -8 on the graph, which I do. Okay, so you can always plug in some points when in doubt. Now you may have noticed on the quiz that I did give you points if you just wrote these transformations correctly. So even if you're not sure about the graph and the shape of the graph or anything like that, make sure you at least write down the transformations on your paper, because if you get the graph wrong, you can still get points for the transformations for just writing those down. You don't have to write them, but if you get your graph wrong, I'll still give you points if you got those correct. All right, number 11. We've got quite a few transformations here. So like I said, always doing that inside transformation first. This is going to make us go left 4. Okay, and then you want to do your reflection right here next. That's going to be -y because it's outside of the parentheses, because it's not inside the parentheses with x. That's going to be a -y, which causes you to, I just put this in parentheses, you can say either one. You can either say -y or reflect over x. Those are the same thing. Okay, and then up 2. Okay, so let's do that. This is the quadratic function, so that's going to be your parabola. Okay, so we're going left 4. We're reflecting over x, which just means your parabola is actually going to go upside down. And then we're going to shift up 2. Okay, so there's my vertex, which is just the point right here, that turning point on your parabola. Okay, and then you can just sketch the graph. So over 1, down 1, because 1 squared is 1. Over 2, down 1, 2, 3, 4, because 2 squared is 4. If I went over 3, 3 squared is 9, so I would need to go down 9. From my vertex, I'm going over 3 and down 9. So that would be the next point if you kept going. All right, there you go. Number 12, our square root function. So this one looks like that, kind of. A little bit better. No. Okay, something like that. We've got a 1/2 being multiplied by the x. That's your only transformation. Remember, if it's inside with x, it does the opposite. So that is going to be 2 times x. All right, I'm going to graph the original parent function. So normally it looks like this. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. So those are your original points before we multiply x by 2. Now let's multiply our x's by 2. Well, 0 times 2 is still just 0. The x value here is 1 times 2 is 2. The x value here is 4 times 2 is 8. 1, 2, 3, 4. So those are my new points. Just took my x's and multiplied them by 2. It's called a horizontal stretch. All right, next page. All right, determine whether the functions are inverses and prove it algebraically. You have to have the algebra on there to get credit for these. Make sure you work it out. You can't just say yes or no. You have to work it out. So remember, what we do is we find f of g of x, and it needs to come out to x. And then we need to find g of f of x, and it needs to come out to x. And then that means that they are inverses. If one of those does not equal x, if either one does not equal x, then they are not inverses. Okay, let's try it on number 13. So we'll start with f of g of x. So that is 2. We are plugging g in for x here. So I'm going to just leave some big parentheses for now and keep writing f. So there's the function f, but I just left some parentheses where the x normally goes. Okay, now I'm going to take g and plug it in. All right, now we have to simplify, which is where we might have some trouble. Okay, right here you've got 2 divided by 2. Those can cancel. 2 divided by 2 is 1. 3x plus 5 minus 5. Okay, we're left with that. Now notice you've got plus 5 minus 5. Cancel. 5 minus 5 is 0. All right, and then I've got 3 divided by 3. That's 1, so those also go away. And that leaves you with x. Okay, that's exactly what we wanted to happen. That is step 1 right here. F of g of x needs to come out to x. All right, next one, we need to do g of f of x, so same thing, but now plugging f into g, and we want that to come out to x as well. So start by writing g, but leave a big parentheses where the x goes. Okay, now I'm going to plug f in. That is 2x minus 5 over 3. Okay, again, 3 divided by 3 cancels. You could distribute the 3 here if you wanted to, and then cancel it later, but it's obviously much easier to recognize it right there. That 3 divided by 3 goes away. All right, and now we've got negative 5 plus 5 is 0. And now 2 divided by 2. So it all simplifies to x. So since both of those simplified to x, your final answer is yes, they are inverses. Let's see what happens on 14. So first we're going to start with f of g of x. So start with your function f, leave some parentheses where the x goes. And now I'm going to plug in g, which is x plus 12 over 5. Okay, 5 divided by 5 cancels. Things are looking good. Got two 12s. Oh, but they're both positive. 12 plus 12 is not 0. It is 24. So since those 12s did not go away, this is not equal x. And so these are not inverses. Not inverses because it didn't come out to x. And that's it. You don't have to do g of f of x because only one of them has to fail in order for them not to be inverses. All right, now let's graph f of x, find the rule for the inverse, graph it, and then get the domain and range. So we had some trouble with these. This is our new material, so make sure you practice this one. Graphing the line. Hopefully this doesn't cause us trouble. This is your y-intercept at +1 on the y-axis. The slope is 1/3, so you're going to go up 1 over 3, up 1 over 1, 2, 3. That gives you your next point. Okay, so here's my original function. All right, let's get the inverse. The rule for the inverse. To do that, remember you're going to switch x and y and solve for y. So this is the same thing as y. I'm going to put an x there. And instead of x, I'm going to put y. Now let's solve for y. I need to subtract the 1 over. To get rid of 1/3, that's kind of tricky maybe there. To get rid of 1/3, we're going to multiply by 3 on both sides. Multiply by 3. Okay, so let's distribute this 3 into the parentheses. That gives me 3x minus 3. So my inverse is 3x minus 3. Okay, I can graph that by starting again with the y-intercept at -3. And using a slope of 3, I go up 3 over 1, because if this were a fraction, it would be over 1. So up 3 over 1, up 3 over 1, and so on. Now remember, the other way to graph an inverse is to switch, start with the original graph, switch x and y, and plot that point. So look at this point here on my original function. That is at 0, 1. Now if I switch x and y, I get 1, 0. Well, look at this point on my inverse, 1, 0. That's all it is. I took x and y and I switched them. Let's pick another point, this point here. That is at 1, 2, 3, 4, 5, 6, 3. So what point should be on my inverse? 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. And there it is. Okay, so if you can't graph the inverse, if you're having trouble graphing the inverse from the function, you can always get the points from your original function and switch x and y and plot that point. Just switch x and y and plot your new point. I don't care which way you graph it. Okay. Domain and range, these are both lines, so you see arrows going in both directions. Domain is all real numbers, range is all real numbers. Also, you can tell that the domain and range is all real numbers because there is no denominator with an x, and there is no square root. So that tells me my domain is all real numbers. And then because I know this is a line, the range is also all real numbers. Okay, let's continue. Number 16. Okay, so we want to first graph that. This one's a little tricky, the way that it's written. So let me rewrite that. This is the same as the square root of negative x plus 2. Okay, so this is going to make your graph go left 2 and then negative x, which makes it reflect over y. Okay, so I'm going to go left 2 first, but then I'm going to reflect that point over the y-axis, which puts me here. I know now it makes it look like I went right 2, but that's why we have to do the transformations in that order, because that's what's supposed to happen. Left 2 and then reflect over y, it puts me there. Now remember, normally your graph goes that way for the square root, but since I reflected over y, it should now face the other direction. So it should look like this. If you're not sure, just plug some points in for x and you'll get the y value. All right, now let's get the inverse. So we're gonna do x equals the square root of 2 minus y and solve for y. So I'm gonna square both sides to get rid of the square root. I'm gonna subtract that 2 over. And now divide by negative 1, which changes all my signs. Negative x squared plus 2. Okay, now I can graph that, but domain and range is important here because we know there is a restriction on the domain when you're talking about square roots. So that would be 2 minus x is greater than or equal to 0, right? What's underneath the radical has to be greater than or equal to 0. Add that x over. I like to flip it around. X is less than or equal to 2. So if this is my domain for the original, then that means it's my range for the inverse, right? We switched x and y, so we also switch the domain and range. So I have y is less than or equal to 2 because of this domain. And then my range for the original, well, I can tell by looking at the graph, my range for the original is y is greater than or equal to 0. But I can also tell that by looking at the function, because the square root of any number is always going to give me a number greater than or equal to 0. It's going to always be positive. So I can get it that way as well. That means my domain for the inverse is x is greater than or equal to 0. Okay, so what this tells me is that I'm only graphing the right half of the parabola. Whoops, not parabole. Okay, normally your quadratic looks like this, but I'm only going to graph the right half, which means it's going to look like that, something like this. Okay, so go to your graph. This parabola has shifted up to and reflected over x. Up to and reflected over x, and I'm only graphing the right half, so it should look like this. And there it is. That's up 2. This is reflect over x. Remember, you can also take these points, switch x and y, plot the new point. So for my point here, that is 2, 0. So I should have the point 0, 2 on my inverse, and so on. So you could do that with all of the points if you wanted to graph it. All right, now we've got our piecewise function. Okay, so we had some trouble with these on the quiz as well. Remember, what you're doing is you're graphing this function, but only for these x values. You're graphing this function, but only for those x values. So what I like to do is just graph the whole thing and then go back and say, but I only want it for x is less than 2. Okay, so x squared minus 2, that's going to be a parabola shifted down 2. So here it is. Two squared is 4. That's how I know to go up 4. Okay, but I only want to graph that for x values less than 2. Well, perfect. That's actually only where I graphed it. So I only want these points and to continue on that direction, less than 2. However, since there's no equal to, I need to have an open circle on my graph. So right here, open. All right, let's keep going. This is a line, so nobody should be missing this. You've got a y-intercept at 2 and a slope of -1. So start at positive 2 and go down 1 over 1, down 1 over 1, down 1 over 1. That's how you get a slope of -1. And I only want to graph that actually for x values greater than or equal to 2. So it's going to start right here. And so I can erase these other 2 points. That's why we need to use pencil. And there's my graph. The domain of this would be all real numbers, because as you can see, you've got an arrow going to the left forever, to the right forever. And even right here where the graph is broken, there's still a point. So no worries about your domain there. All right, and then the range, you can see that it's going down forever and up forever. And even at this broken part, the y values are all covered. So that's all real numbers. All right, last part, finding the domain. Remember, your only restrictions on domain come from 2 things. The 2 things are the denominator you can't divide by 0. So if you see a denominator or a fraction, the bottom cannot equal 0. Solve for x. And then you've got square roots. What's under the square root has to be greater than or equal to 0, because you can't take the square root of a negative number. So those are only 2 things you're watching out for, and otherwise it's all real numbers. So number 18, I don't see a fraction and I don't see a square root, so it's automatically all real numbers. I can plug anything in for x. Number 19, I've got a fraction, so the denominator cannot equal 0. Subtract 9, divide by 5, and that's the answer. X cannot equal -9/5. Okay, number 20. This time I have the square root. So I'm going to say 2x plus 13 has to be greater than or equal to 0. Solve for x. Divide by 2. X has to be greater than or equal to -13/2. or you could say negative 6.5 if you wanted. All right, that concludes the review video. I hope that helps everyone who watched this